Hello everyone. Today we will discuss about junction transistor. Transistor is a combination of two words, transfer and resistor. That means current is transferred from the lower resistance to the higher resistance, that is from input to the output section. So transistor is formed by sandwiching one extrinsic semiconductor between other type of extrinsic semiconductor. For example, in case of NPN transistor, one p-type semiconductor is sandwiched between two n-type semiconductor. Similarly, in case of PNP transistor, one n-type semiconductor is sandwiched between two p-type semiconductor. Here is an example. Here p-type semiconductor is sandwiched between two type semiconductor. Similarly, if n-type semiconductor is sandwiched between two p-type semiconductor, then this is PNP transistor. So we can divide that three terminals. This is emitter, this one is base, and this one is collector. And the symbol of NPN transistor is this one. This is NPN transistor. This arrow mark indicates the direction of current. Here in case of PNP transistor, this arrow mark gives the direction of current. Always this arrow mark is on the side of emitter. We have to remember this one. Okay. So this is actually the transistor, real transistor. This is emitter, base, and this one is collector. You can see the pointer is at the collector. So in case of NPN transistor, always we have to remember that emitter base terminal is always forward bias. That means base is connected to positive terminal and emitter is connected to negative terminal. Okay. Similarly, collector base is always reverse bias. That means N type is connected to positive terminal and P type is connected to negative terminal. Okay. So current always flows from here and here. So if IB plus IC flows in this direction, IB and IC flows in this direction, so IE is equal to IB plus IC. So this is the block diagram, okay, and this is the circuit symbol. So emitter base battery is called emitter base voltage battery, and this collector base terminal battery is called the collector base voltage. Always we have to remember that this collector base is always reverse bias and emitter base is always forward bias, and this type of transistor is called common base transistor because base is common to both input and output. Okay, so here the point, the emitter junction is always forward bias and collector junction is always reverse bias. So the electron always flows from emitter to base towards the collector. So when the electron flows, less number of electron recombine with the hole because there are some holes in the base terminal because this is NPN transistor. So middle section they will recombine with the electron repelled by the emitter. So it is very less, that is 5%, and 95% of electron will attracted towards the collector because collector is always reverse bias. So as we know, IE is equal to IB plus IC. So similarly, in case of PNP transistor also, this base emitter is forward bias, Okay, so base base is n, so this one is connected to negative terminal of battery and emitter is connected to positive terminal of battery. So this one is forward bias and base emit collector is reverse bias, so collector is connected to negative terminal and base is connected to positive terminal. So this is collector base voltage and this one is emitter base voltage. So holes from the emitter are repelled towards the base. Okay, so less number of electron will recombine with the holes repelled by the emitter, that is very less 5%, and other 95% of holes will be attracted towards the collector as it is reverse bias. Okay, so most of the holes are attracted towards collector, so the direction of current is same as that of hole. As we know, the current direction is along the direction of positive charge carriers, so this is the direction of current. Okay, so if this direction is IE, then IB is this direction and IC is this direction, so IE is equal to IB plus IC, and this is the circuit symbol. Okay, same, this emitter base is forward bias and collector base is reverse bias. Here we have to remember that this arrow mark, it always is at the emitter. Okay, and it shows the direction of current. Okay, here you have to remember emitter junction is forward bias and collector junction is reverse bias. So same here also, holes repelled by the positive terminal of battery is attracted towards the base. Okay, and less number of holes will recombine with the electron at the base, and most of the holes will attracted towards the collector, because collector is reverse bias. So 95% of holes will go towards the collector and 5% will go towards the base. So total current here also same, that is IE is equal to IB plus IC. This formula we have to remember, very important formula. Okay, so if we will find the characteristics, input and output characteristics in case of PNP transistor, we need a emitter at the input and at the output also. To get the voltage, we need a voltmeter at the input. So as it is connected to emitter base, so emitter base voltage this one. Okay, and this is emitter current. Here we can find out the emitter current. Okay, similarly here also we can find out the collector current. To get the collector base voltage, we need a voltmeter which is always connected in parallel. We have to remember that a voltmeter is always connected in parallel with the circuit and emitter is always connected in series with the circuit. Here we have connected a voltmeter in parallel with the circuit, and this one is a rheostat. Okay, this is rheostat, this is voltmeter, and this one is emitter. So we can find input characteristics. So to find the input characteristics, we have to draw characteristics between input voltage, that is base emitter voltage, and input current, that is emitter current IE. So IE is taken along the y-axis and emitter base voltage is taken along x-axis. So you can get the characteristics. Here we have to remember that the output voltage, that is collector base voltage, is always constant. So we can plot three graphs. Here we can see collector base voltage is at 0 voltage, then the graph will be like this. If it is 10 volt, the graph will be like this. If it is 20 volt, then the graph will be like this. Actually this one is minus. Okay. Similarly, for output characteristics, here output current is IC. This is IC. Okay. By this emitter we can collect the output current. Okay. So IC is the output current and VCB is the output voltage. So this is the graph. Okay. Here we have to remember that in case of output characteristics, the input current is always constant. In case of input characteristics, output voltage is constant. In case of output characteristics, input current is constant.